Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics and six, and this is November 2023 exam. So we just gonna try by all means to work out the questions that you're given on question number 3 on integration with the use of partial fractions. All right, so use partial fractions to integrate the following. So we are supposed to integrate these integrals using our partial fractions. So the first part, that is 3.1, is the integral of 2x squared. So this is 2x squared minus 7x minus 12, like this, over x into x plus 2 into the bracket of x minus 3 with respect to x. All right. So this one, we do not have much on this question. It was just like straightforward our N5. This was a straightforward our N5. We do not have anything that is special here. All right. So if we check the denominator, there's x and x and x. So meaning to say, x was going to be to the exponent of 3. So it has the higher exponent as compared to the numerator. So this is a proper fraction. So if it is a proper fraction, there is no need for us to change anything. We're just going to express this into partial fractions. So we're going to let our expression of 2x squared minus 7x minus 12, everything over x into the bracket of x plus 2 into x minus 3 to be equal to, these are linear factors that we have linear brackets. So meaning to say we shall have a over the first linear bracket, which is x, so it's a over x plus b over the second bracket of x plus 2 plus c over the bracket of what? Of x minus 3. So like I said, this one, it was a straight part. Already they factorize this for us. It's not like you are starting to factorize. No. So equating the numerators, so that will be the numerator from the left-hand side, which is 2x squared. So you're going to have 2x squared minus 7x minus 12 is equal to the numerator here, which is a. So that's a into, so you're going to divide x, and x here will cancel. You remain with these two brackets. So you're going to cancel there. You're going to remain with the bracket of x plus 2 into the bracket of x minus 3. All right, you do the same thing, plus b, the bracket of x plus 2 and x plus 2 cancels. You remain with what? If it cancels, you remain with x and the bracket of x minus 3. So this will be bx into the bracket of x minus 3 plus c. We do the same thing, x minus 3 here and x minus 3 cancels. So you remain with x and x plus 2. So this will be x into x plus 2, just like that. All right, so these are linear brackets. These are linear terms that we have. So also we can let each of these brackets start with x plus 2. There's x plus 2. Also, there's x plus 2 here. So you can let the whole of that bracket of x plus 2 to be equal to 0. That means if this is a 0, we have eliminated the whole of this term. The whole of this part we have been eliminated, was anything multiplied by 0, it becomes a 0. But we need to know the value of x when this x plus 2 is equal to 0. What is the value of x there? X is going to give us a minus 2. Transpose this. So when x is equal to minus 2, we have to substitute on the left-hand side. Wherever there is x, we're going to substitute minus 2. So here we just need a calculator direct. There's no need for you to write anything. They just substitute in place of x. That's going to be 2 into x, our x, which is minus 2. So that's minus 2 squared. All right, minus 2 squared minus 7x. So this will be minus 7 into the bracket x, which is minus 2. That's minus 7x. All right, so it's going to be minus 2. All right, sorry for that. My calculator is just a little bit slow. I think I've been recording for so long today. All right, so here let me just remove this one and put it as and it's just like this. So it's going to be a 10. So this will give us 10 is equal to, you do the same thing on x here. So there's no need, because we say the bracket of x plus 2 is a 0. So this wall is a 0. Also this wall is a 0. So we're going to substitute our x, which is 2 on b there. So on b, if our x is minus 2, this will be minus 2 times the bracket of x minus 2, x minus 3, where x is minus 2. So that will be minus 2 minus 3 like this, and this will give us a positive 10. So that's 10 times b, which is 10b. So this is going to give us the value of what? The value of b by dividing by 10 by 10. So b is going to be a 1. All right. With the same knowledge, we are going to apply it again on the second bracket, the bracket of x minus 3. We are done with this bracket of what? Of x plus 2. We used this to find the value of b. So now we are going to focus on the bracket of x minus 3. If we let this bracket of x minus 3, it's a linear term, so it's easier for us to let it to be equal to 0. So it means we have eliminated the whole of this and also the whole of this. If this becomes what? A 0. But what is the value of x? If x minus 3 is a 0, the value of x here is going to be equal to what? It's going to be equal to 3. Transpose x is going to be a 3. So you're saying when x is equal to 3, what is going to be the answer on the left-hand side if x is equal to 3? So it means wherever there is x, we are going to substitute what? A 3 on that side. So this was going to give you a negative 15. Substitute 3 here, you substitute 3 here, you're going to get a negative 15 is equal to, so there's no need for us to substitute here because there's what? X minus 3. Also here there's x minus 3, so we substitute where we do not have x minus 3. So you're going to substitute x, which is 3 here, and also x, which is 3. So 3 plus 2, that's a 5 times 3, which will be 15c. So just substitute on your calculator, divide by 15. C is going to give us a negative 1. All right. So that is how we could have calculated our C in this case. So with the same idea again or knowledge, we're going to work with x this time. As you can see, there's also a linear term here, which is x. We have x here. We also have x there. So we relate every part to be equal to 0, every linear part. So we're going to let x to be equal to 0. So already x is equal to 0. There's nothing that we are solving there. So it means this whole thing is going to be a 0. This whole part is going to be a 0. So we're going to substitute a 0 here, a 0 here. So you're going to get a negative 12. So negative 12 is equal to, we substitute a 0 here and on this one. So that will be 2 times minus 3, which is what? Minus 6. So that will be minus 6a. So a is going to be a positive 2. All right. So these are the values that you want. The value of a here, the value of b, and also the value of c. With these values, we are going to substitute so that we'll be able to integrate whatever that we are given with respect to x. So having this, we can say that from this a over x, our a is 2. So we are supposed to get 2 over x plus b over x plus 2. Our b is 1. So this was supposed to be plus 1 over x plus 2. All right. Plus c over x minus 3. Our c is minus 1. So it's going to be minus 1 over x minus 3. So like I said, this was a straightforward integral because here we're just going to integrate each and every part with respect to x. And as I say, this is, we are back to our, this is exactly what we had in N5, guys. Let's be honest. So this one is going to give us 2 ln of x, all right? And here we're going to get ln of x plus 2. Ln of x plus 2 here minus ln of what? Of x minus 3 plus the constant of integration. So that is what we're supposed to have at the end after integrating each and every part. So I think this one, I don't know what actually happened in this exam. For those who wrote this exam, this was an advantage for you guys. Already they factorized this for you, and they are linear. We do not have any quadratic or any repeated linear. They are straight linear terms. Those are derivative. Those are partial fractions for N5. Those are partial fractions for N5. So it was a revision actually for N5, this one, which is an advantage for those who wrote this exam. Also 3.2, it was an application of N5. If you check properly, only that year they did not factorize for us. But if you check, it was same application again, x cubed plus 4x plus 9 over, this will be x squared minus x minus 6. So if we check here, like I said, the first thing is to consider that on our partial fraction, we can see the exponent of the numerator is bigger than that of the denominator. So this here, once you have this bigger than, it means this fraction is an improper fraction. It is an improper fraction. So how do you work out an improper fraction? You are supposed to factorize, to apply your long division, right? Yes, we know this x squared, this one it can be factorized. We know that this x squared minus x minus 6, we can factorize this. You have two brackets, we've got x here and x, factors of minus 6, but these factors add up to minus 1. We've got minus 3 and a 2. So these are the factors, minus 3 here and also a plus 2. We have factors, which is fine, but the fact that the numerator, it has a bigger exponent than compared to the what? To the numerator, you're supposed to apply long division. Remember your long division, that one for n5, all right? X squared minus x minus 6 into what? The numerator, which is x cubed. So this is supposed to be followed. We do not have x squared, so you can write it as 0x squared. All right, then we've got x here plus 4x plus 9. So here, just writing like the format ax cubed plus bx squared plus cx plus d. We just want that format of a cubic expression, not to say it's a must for you to write that 0. No, it's not a must. So remember the division, first term versus the first term. So x cubed divided to x squared, this is going to give us x. Then the number or the term that you get here multiplies everything here back, every term. So it is going to be x times x squared, which is x cubed. X times minus x, it will be minus x squared. X times minus 6, it is going to be minus 6x, like that. So we subtract this part from what we have on the original term. So the purpose of having a 0, it is because so that we can properly the x squared under x squared. So we subtract x cubed minus x cubed, that's a 0 there. 0 minus x squared. So minus and the minus, it will be a plus. So this will be plus x squared. 4 minus, it's going to be a plus. So that's 4 plus 6, which is 10x. 4 plus 6, that will be a 10. So you're going to have 10x. All right, so that we have subtracted these terms. But after subtracting, what do? We have to drop the terms that are remaining. There's a 9 that is remaining there. We just have to drop. There's no terms considered, or you can just use like a 0 term, just like 9 minus a 0, which is just a 9. All right, so this is what we have. So what are we going to do? We divide. Is it possible for us to divide the first term versus first term? It's possible again, because x squared and x squared is a 1. X squared divided to x squared, that's a 1. So this will be plus 1. Whatever that we get here multiplies everything. So this 1, it has to multiply everything in this quadratic. So let us multiply 1 times this. It remains as it is. So it's going to remain as it is, x squared minus x minus 6. We are multiplying by 1, guys. It does not change anything. Then we subtract, just like the previous case. X squared minus x squared, that's a 0. We no longer have this x squared. So it's now 10 minus x, which is minus 1 actually. So it's 10 minus, which is what? Minus and minus is a positive, all right? Sorry for that. So this will be minus here, which is what? A positive. So meaning to say 10 plus x, it will be 11x. 9 minus again is a positive, all right? So meaning to say if we subtract this, we're gonna have what? 9 minus, which is gonna be a positive 15. 9 plus 6, which is a 15. So this will be 11x. So this is gonna be like this in the actual sense. All right. So you're supposed to be very, very careful. Very, very careful in your simplification. So I've got a 15. The way I'm writing my 15 here is like it's a 15. 9 plus 6, which is 15. So this is what we are having, 11x plus 15. And we can't divide, like 11x divided by x squared is impossible. So this represents your remainder, the one that we are failing to divide later on. So this here represents what you call your remainder. This is now your remainder. So this is what you're going to do. You are going to take the first term. Remember after this, after you have divided, you're going to write this as we got this as the exact term, which is x plus 1 plus the remainder. So you're going to take the remainder, which is 11x plus 15 over what was dividing. We were dividing by x squared minus 6x minus x minus 6. which is in this case is the one that we think, okay, no problem, let me just write so that I do not confuse. It was supposed to be like this, x squared minus x minus 6. But this whole part, guys, is the one that I said, if you factorize it, it's going to give us two brackets, x minus 3 and what? X plus 2. All right, no problem. So we're going to just leave it like that. So this remainder part is the one that you're going to take this one. You express this into partial. This is the one that you express into partial fractions. So you're going to express the remainder into partial fractions. So that's where you're going to have now your partial fraction concept. This one is already fine like this as it is. So we need this 11 plus 5x plus 15, this one. So we're going to take this as it is, 11x plus 15, our remainder over, remember it's over this quadratic x squared minus x minus 6 over x squared minus x minus 6. That was our remainder in this case, which is the same as this one. Remember, after factorize, we got two brackets, x minus 3 and what? And x plus 2. So you're going to have two brackets, x minus 3 and x plus 2 here. So this is the same as we've got 11x plus 15 over two brackets of x minus 3 and x plus 2. All right, so into partial fractions, what are you going to have? Again, we've got linear terms. So these are linear terms that we are having. So this will be equal to a over the first bracket, x minus 3, plus b over the second bracket, which is x plus 2. So by equating the numerators now, which is in this case, we are working with what? 11x plus what? 11x plus 15. So this numerator of 11x plus 15 must be equal to a. All right, so you're going to have a into the bracket of x minus 3 here. X minus 3 cancels. You remain with x plus 2. So this will be x plus 2 plus b here, x plus 2 and x plus 2 will cancel. So what are you going to remain with? X minus 3. So this will be b into x minus 3. So these are linear brackets. So you can let each of these to be equal to 0. If we let the bracket of x plus 2 to be equal to 0, what does it mean? It means x at that moment will be equal to minus 2. And if x is minus 2, what are we going to have? All right, let us simplify. If our x is minus 2, let us have it this way here. So this is 11x. Let us have our calculator here. So this is 11 x, which is 11 times negative 2. Whatever that we get here, we add 15. So we're going to add 15, which will be minus 7. All right, so that's minus 7 on this side. Minus 7 is equal to, in place of x here, going to be minus 2. So minus 2 minus 3, that will be minus 5b. So divide by negative 5 by negative 5b is going to be a positive 7 over 5. So with the same knowledge or same idea, we're going to let this bracket of x minus 3 to be equal to 0. If we let this bracket to be equal to 0, it means x at that moment will be equal to 3. So we can substitute on them. Left-hand side, now our x here is a 3. So this will be 11 times 3 plus 15, which will be 48. So this will be 48 is equal to, here there's a 3 in place of x. So 3 plus 2, that will be 5. So this will be 5a divided by a. So by 5, I mean. So this will be 48 over 5. So we have our a and we have our b in this case as of the partial fraction of the remainder that we had here. So meaning to say, from our simplification here, we said we are going to express this into partial fraction, which is the remainder. And we said, so this is going to be written something like this. It's going to be x plus 1 like this, plus into partial fractions. This is supposed to give us what into partial fractions? It is supposed to be a over x minus 3, all right? So that's why we've got a over x minus 3. This is our a, which is 48 over 5. So it's a over x minus 3, remember? All right, so we're going to take this. Let me reduce a little bit, guys, a little bit here. A over x minus 3, there on top there, a over x minus 3. So it's plus here, a, which is this, our a here, 48. So it's going to be 48 here over 5, like this, over x minus 3. This is a over x minus 3. All right, plus b over x plus 2. So this is b, which is 7 over 5, so it's plus b 7 over 5 like this over x plus 2. X plus 2. All right, so we've substituted our a and b from the remainder. So meaning to say, this is what we are remaining with. And we are supposed to have an integral of this here part with respect to x. So as we can see here, x, we add 1, so that will be x squared over 2, plus the integral of 1 with respect to x, that will be x, plus here we've got 48 over 5, so this is same as we've got 48 over 5 like this. The integral of 1 over this x minus is a ln, so it will be ln x minus 3 like this, plus 7 over 5, we take it down, so this is 7 over 5, the ln of what? X plus 2, so it's going to be ln of x plus 2 plus the constant of integration like that. All right, so that's it. That's what we are going to have at the end. That's what you're going to have, right? Yes. So guys, we just have to work with more questions as much as we can. We just have to play around these questions and see how do they actually ask these typical questions. But we just have to expect to work with more of these from our past exam papers. But as you can see, it's something that is just straightforward. Sometimes you just have to be very, very careful in your simplification, expansion, and to know the format of the expression that you're given. All right, if the as long the numerator has got a bigger exponent, it's referred as an improper fraction. If you check the first equation that we had, it was a proper fraction because it is 2 here. That's why I was saying if you expand this x and x, it's going to be x squared times this x, it is going to be x cubed. So it's a proper fraction, it must have a lesser exponent. But once the numerator, it can be like this, x squared plus 2x plus 1 over x squared minus x minus 6. Once the numerator, as long they are of same, or the numerator has got a bigger x, as long they are equal, it's now an improper fraction. Once it increases 3, 4, 5, an improper fraction. So the numerator is not supposed to have any exponent that is equal to the denominator or bigger than. It is supposed to have a lesser exponent. Always, it is supposed to have a lesser exponent. Once they are equal like this, or once it is bigger like this, you have to apply long division first. Before anything, you are supposed to have applied your long division. Then you express the remainder into partial. The remainder, all right, is the one that you express into partial fractions. That is the idea of these questions. All right, so like I said, we hope for more questions to come.